Okay, so here's still arithmetic progression, AP. Remember the formulas when you're looking for the value of a term in arithmetic progression. You use a plus n minus 1d, where n is the term you're looking for, a is the first term, and d is the common difference of that progression. And the sum of terms, which is Sn, equals to n over 2 into a plus n minus 1d. The notations still retain their meanings. And here is a third formula, Sn equals to n over 2 into a plus n. You use this formula when you are given the last term of the AP. When you are given the last term of the AP, you make use of this formula. So now we'll just do an example on the arithmetic progression. It's from the past question, 2015. It's a question in 2015, and it goes by: the first term of an arithmetic progression is 8. If the ratio of the 7th term to the 9th term is 5:8, find the common difference of the AP. I'll go over the question again. It says the first term of an arithmetic progression is 8. That is, A of that arithmetic progression is 8. It says the ratio of the 7th term to the 9th term is 5:8. I believe you still remember ratio in mathematics. Ratio of the 7th to the 9th term, that's T7 ratio T9 equals to 5:8. Now find the common difference of the AP. Here is all the parameters we've been given in this question. A is 8, first term is 8, T7 ratio T9 is 5:8. Now remember, Tn equals to a plus n minus 1d. I can go ahead to look for a formula for T7 by saying T7 equals to a plus n now is 7 minus 1d, which equals to a plus 6d. And T9 equals to a plus 9 minus 1d, which is equals to a plus 8d. Now, AP is also a very logical question, or a very logical topic in mathematics. When you have T7, it will always give you a plus 6d, T5 a plus 4d, T3 a plus 2d. The difference is just the coefficient of d, which is just one less than the term you are looking for, or the term you are considering. So that means, considering this expression here, this equation here, I have a plus 6d over a plus 8d equals to 5/8. I'm sure you understand what I did here. Ratio also means division. So a plus 6d over a plus 8d equals to 5/8. I can make this simpler by doing a cross multiplication, such that I have 8 into a plus 6d equals to 5 into a plus 8d. Opening the bracket, I have 8a plus 48d equals to 5a plus 40d. Then I go ahead to collect like times by bringing all a's to one side and all d's to the other side. So I have 8a minus 5a equals to 40d minus 48d. So this gives me 8a minus 5a, 3a equals to 40d minus 48d, that's minus 8d. Remember, we've been given a from the question, a equals to 8. So I can substitute for a in this particular equation, which gives me 3 into 8 equals to minus 8d. 3 into 8 goes ahead to give me 24 equals to minus 8d, which when I divide both sides by minus 8, minus 3 equals to d, that is 24 divided by minus 8, d equals to minus 3. So there you have it, the common difference of this arithmetic progression. So remember, consider your formula, look into your parameters well, cross multiply if need be, expand the bracket, substitute properly, and you'll definitely get your answer. So here's another question in arithmetic progression. taken from your past question 2016. But this question is quite different from the first one we solved, because this is requesting that we look for the sum of the arithmetic progression. The question says, find the sum of the arithmetic progression 1, 3, 5, ... 101. So this is the arithmetic progression. 1, 3, 5, 101. This is to tell you that the first term of this arithmetic progression automatically is what? 1, and the last term is 101. They gave this ... just to indicate that there are a series of numbers here, but they'll just prefer to just go ahead to write the last one, the first 3, and the last term. Now they're telling you to look for the sum of terms. You can actually go ahead to look for what term this last term is by looking for n using this formula, then now using this to solve this question. But rather than do that, which is a very long process, just use this formula. Sn equals to n over 2 a plus l. So we'll be taking another question on that AP arithmetic progression, but this question is quite different from the one we just did, because here we've been asked to look for the sum of this arithmetic progression. The question says, find the sum of the arithmetic progression 135 ... 101. So here it is. Find the arithmetic progression 1, 3, then 101. Now for this arithmetic progression, we've been given the first term, the second term, the third term, and the last term of the arithmetic progression, and they will love us to calculate the sum of all terms in the arithmetic progression. So I can go ahead and start looking for the rest of the terms, or just look for what term this is and then use it to look for the sum of that term. So looking for what term that is, remember our formula Tn equals to a plus n minus 1d. Since I know the value for the nth term, which is 101, I know a, which is 1, and d, automatically d is the common difference. That is the difference between the second and the first term, or the difference between the third and the second term. So just doing that, 3 minus 1 here, 2, 5 minus 3 here, 2, which makes the common difference 2. So d equals to 2, a equals to 1, and Tn equals to 101. All this is in a bid to look for the value of n. So substituting now, 101 equals to 1 plus n minus 1, 2. So that is 101 equals to 1 plus, opening the bracket, 2n minus 2. 101 equals to 1 minus 2, that is minus 1 plus 2n. Collecting like times, I have 101 plus 1 equals to 2n, 102 equals to 2n, dividing both sides by 2, 51 equals to n, which means n equals to 51. That means 101 is the 51st term of this particular arithmetic progression, and is also the last term of that progression. So now I can go ahead to look for the sum of terms in this progression by using the formula Sn equals to n over 2 into a plus l. Remember, L is the last term of the progression. So Sn now, that is S51 equals to 51 over 2 into bracket, A is what? 1 plus L is what? 101. So S51 equals to 51 over 2 into bracket 102. This is the same thing as 51 over 2 times 102. 2 here 1, 2 here 51. 51 times 51 gives us 2601. So 2601 is the sum of all terms in this arithmetic progression. That is, if I were to add one by one, 1 plus 3, 3 plus 5, 5 plus 7, 7 plus 9, up on to the 51st term, the sum would give me 2601. So now, geometric progression.
Stop. Are you ready for the geometric progression? You start on that page, right?
Yes.
I want to start a new sheet.
I'm starting. Write the formula.
Okay.
Do example on the new sheet.
Right.
Where's the example? Where is the example?